Now, in today's lecture, we have to focus on the difference between surface soil and subsoil. Now, see the difference? We know surface soil is also called as topsoil or also horizon A, while horizon B is called as the subsoil. Now, see the differentiating point? Surface soil is defined as the immediate uppermost loose layer of the earth consisting of organic matter and soil organisms suitable for plant growth. It is generally called furrow-sliced soil layer and it is the fertile soil. What about the subsoil? Subsoil is defined as the compact soil below the surface soil. It is generally poor in nutrient and organic matter and hence it is less fertile than that of surface soil. Surface soil is completely weathered while subsoil is partially weathered. Surface soil is dominated by fine particles like silicate clays, while subsoil is dominated by quartz particles and other fragments of minerals. Surface soil is porous and friable, while subsoil is massive and compact. Aeration in surface soil is good and exchange of gases between atmosphere and soil air takes place. While in subsoil, aeration is very poor and hence exchange of gases is very much limited. Now see the next points regarding surface soil. The number and activity of soil microorganisms is high, while in subsoil, microbial population and their activity are very low. Relatively higher organic matter content due to presence of higher biomass on the surface soil. While in subsoil, due to lack in plant and animal residues in the subsoil, the amount of organic matter is very low. Due to presence of high organic matter content, the color of surface soil is deep brown or dark, while color of subsoil is light. It may be light yellow, depending on the nature and kinds of unweathered materials. Surface soil is more fertile. Most of the essential plant nutrients are present in it, while subsoil is less fertile. Very few essential plant nutrients are present. Cation exchange capacity is high in surface soil, while cation exchange capacity is low in subsoil. It has good physical management condition because of surface soil. But subsoil have very poor physical conditions. Now then we go for the next point, composition of soil air in surface layer. First composition is oxygen. Microbial activity requires oxygen to which they take from soil air. The oxygen content is usually lower in subsoil than in the surface soil. As we discussed earlier that in dry season, the soil contains less high amount of oxygen and less amount of water and vice versa during monsoon. Second composition is carbon dioxide. It is the most varied constituent of the soil. It increases with increase in quantity of humus in soil. Concentration of CO2 is associated with the microbial activity. Its concentration in soil varies with temperature, moisture content and oxygen supply that controls the activities of microorganisms. Now then focus on next point, that is water vapor, next composition. Soil air contains much more water vapor than atmospheric air. As long as there is appreciable amount of capillary water in the soil. The soil air is saturated with water vapor, and if the soil moisture falls below the level, the vapor pressure begins to decrease. Now see the next one, that is soil aeration. It is an important factor in the normal growth of plants. The supply of oxygen to roots in adequate quantities and removal of carbon dioxide from the soil atmosphere are very essential for healthy plant growth. When the supply of oxygen is low, anaerobic organisms become active and they alter the rate of decomposition, as well as other undesirable fermentation takes place. The accumulation of carbon dioxide in the soil is also injurious to plant growth as it exerts toxic action. It retards the germination of seed also. That means it is a very important factor. Soil aeration thus helps to supplies of oxygen lost from soil and facilitate the escape of carbon dioxide from soil pores. Soil aeration also helps in maintenance of proper soil structure. Poor aeration results in plant diseases, development of toxins and other injurious substances and accumulation of organic acid in the soil. Now then we see the functions of soil. Soil performs mainly three functions: physical function, chemical functions and biological functions. We see these three functions one by one. First we focus on physical functions. Soil acts as a mechanical support for growing plants. The plant is able to stand erect because of the hold exerted by soil on plant root. The roots are unified and they are anchored in soil mass. The soil acts as reservoir of water as well as air. Plants absorb water through their roots from the reservoir, and the roots take oxygen from the air stored in the soil mass. The soil also stores the sun's heat and supplies it to the growing plant. Now then we focus on the chemical functions. Chemically, soil is a storehouse of nutrients due to presence of large number of compounds of both organic and inorganic origin. Inorganic compounds supply nutrients like sodium, calcium, potassium, sulfur, etc. While organic compounds mainly supply nitrogen, hydrogen, and which is taken by plants from water. Oxygen is taken from water as well as from the soil air, while carbon is taken from carbon dioxide of the atmospheric air. Now then we see the third function, that is biological function. We know soil is a habitat of very large number of organisms like worms, insects, fungi, bacteria, etc. Worms like nematodes and earthworms aerate the soil, mix its constituents by passing large quantities of soil through their body, which is ejected as worm cast. The ejected material is in a more pulverized condition and is more fertile than the original soil. Earthworms transfer soil from lower layer to the surface layer. The burrows made by another organism like rats facilitate the entry of air and water into the lower layers, and it helps aeration as well as drainage. Several microorganisms decompose dead plants and animals and convert the complex compounds into simple substances like nitrates, carbon dioxides, etc., and which serves as plant nutrients. Now then we focus on the next point, that is chemical properties of soil, म्हणजेच मातीचे रासायनिक गुणधर्म. Now see these chemical properties. Soil reactions and soil solution is the first chemical property of soil. Out of these, we firstly focus on the soil reactions. One of the most important physiological characteristics of soil solution is its reaction because of soil structure, the solubility of minerals, availability of nutrients, the activities of microorganisms, and the intake of ions by crops greatly influenced by conditions of different reaction in soil. And depending on that, there are three types of soil reactions: acidic, alkaline, and normal reaction. Now see the soil pH. The reaction of an aqueous solution represents the degree of acidity or basicity caused by the relative concentration or activity of H plus ions or OH minus ions present in it. The neutral reaction is produced by an equal activity of H plus ion and OH minus ions present in it. According to theory of dissociation, the activity is due to the dissociation or ionization of compounds into ions. Greater the degree of ionization, greater is the activity of ions. Pure water also shows some conductivity due to their dissociation, and water is dissociated as H plus plus OH minus ions. Now, the product of dissociation of the two ions is a constant as represented by the equation Kw is equals to concentration of H plus into concentration of OH minus is equals to 10 raised to minus 14. Taking the logarithm of the reciprocals, what we get? 1 upon log of Kw is equals to log of 1 upon concentration of H plus plus log of 1 upon concentration of OH minus is equals to 14, where Kw is the ionization constant for pure water at 22 degrees Celsius. Now then we see the pH values. The negative logarithm or a reciprocal logarithm of H plus ion activities or concentration is called as the pH. We can write this pH is equals to log of 1 upon concentration of H plus is equals to, or it may write as minus log to the base 10 concentration of H plus. pH represents the amount of active acidity or intensity of a solution, and its value varies from 0 to 14. When pH is 7, it is neutral. From 0 to 7, it is acidic, and from 7 to 14, it is alkaline. Soils having pH range 6 to 8.5 are considered neutral. Then we focus on importance of soil reaction. Soil reaction influences crop growth both directly and indirectly. Many plants grow well in neutral solution or neutral soil. The availability of plant nutrients depends on the preparing soil reaction. Iron, manganese, zinc, copper, etc. are available in acidic soil, while the availability of phosphates also depends on the soil reaction. Soil reaction influences soil structure. The cations present in soil control the aggregation of colloidal clay. The activity of microorganisms which help in plant growth and crop production also depends on soil solution or soil reaction. Most microorganisms are active in neutral and slightly alkaline soil. The need of fertilizers also depends on the soil reaction. Then it affects the quality of crop by influencing the soil-borne diseases. The rate of release of plant nutrients by weathering of rocks, soil solutions, ion exchange depends on soil reaction. Soil reaction also helps to predict plant nutrient deficiencies at various pH values. It affects the physical condition of soil. The pH of soil value above 8.5 indicates the presence of considerable amount of sodium. If it is near to 8.8 to 8.5, it is associated with saline soils. Then we see soil solutions. The mixture of soil moisture with solids and gases are called as soil solution. Though the film of soil solution is very thin, it is concentration, but its concentration is not uniform. Soil solution are of two types. Inner soil solution, that is, it is a mixture of fine particles and moisture. The concentration and composition of solute is in equilibrium with the solid phase of the soil. And second type of soil solution is the outer soil solution. It is the liquid in large capillary spaces having different concentration than solute particles. Soil solution supplies a part of the food nutrients absorbed by plants from the soil. Soil solution are also obtained due to the weathering of rocks with free water. The free water contains a part of organic matter and carbon dioxide in dissolved state. The free water carrying these various substances and gases in solution is known as soil solution. Then we see composition of soil solution. Soil contains number of salts in solution, which are present both in ionic and molecular forms. In cultivated soils, the solution is dilute, so they appear in ionic state, while on drying of soil, they appear in molecular forms. Cations, calcium 2 plus, magnesium 2 plus, sodium plus and potassium plus are present to greatest extent. In normal soil, calcium 2 plus predominates, while in saline form excess of Na plus is present. In acidic soil, H plus ion is present in large amount, while in alkaline soil, OH minus ions are present in large quantity. In saline soils, sulfates and chlorides are present in excess. Calcium 2 plus and potassium vary not only from soil to soil but also same soil and different times. Now see the factors affecting the composition of soil solution. The composition and concentration of soil solution is not homogeneous, and the variation is due to type of soil, moisture content, action of growth plants, action of soil microorganism, absorption by colloidal complex, leaching effect, season, and cultivation. That means we want to see all these factors which affect on the composition of soil solution. The amount of nitrate is highest when the crop is sown and lowest after it is harvested. At the harvested time or after harvesting, the nitrate amount is very low. Phosphate ion concentration remains fairly constant in the soil. Soil formed in arid regions usually have more concentrated salt solution than those having free drainage. The concentration as well as composition of soil solution is changed by growing plants. Soil microorganisms help to increase concentration of soil salt solution. Nature of soil solution is also affected by continuous leaching of certain ions that are not absorbed or adsorbed by colloids, or if they are present in excess in soil. Seasonal variations, especially temperature and rainfall, change the concentration of soil solution. Concentration of solution varies directly as temperature and inversely as rainfall. Cultural operation also increase the solubility of soil constituents and hence the concentration of the soil solution. Its concentration and composition is also changed by addition of manures and fertilizers. Then we focus on soil solution and soil productivity. For these, we first focus on the nutrient supply. The main function of soil is to supply mineral nutrients to the growing plants. The crop producing capacity of soil is linked with its nutrient supplying power. That is, supply of nutrients from solid to liquid phase and not so much with the total amount of nutrients present in the soil solution. Normal good soil contains more concentrated salt solution than the poor soil. Hence, crop production is also influenced by the nature and proportion of various ions constituting the salts present in the soil solution. Soil fertility also depends upon the proportion of calcium and sodium ions. Fertile soils usually have a ratio calcium 2 plus and Na plus greater than 1. When the proportion of sodium ions increases, the ratio becomes less than 1 and the soil becomes less productive, and in extreme cases it becomes barren soil. The same is the case with calcium and magnesium ratio. A soil supplying a greater amount of nitrate and phosphate ions during the crop growing period is usually more productive. With these words, today we stop here.